We are going to discuss palindromic substrings. It is again one of the DP problems. The reason why it is categorized within DP, we'll discuss more about it. But this question is very similar to the question that we did yesterday. That was longest palindromic substring. What is the longest palindromic substring that we can get? So this question that we are going to discuss today is very similar to this. We just have to do some minute changes. We have to do count plus plus and all, and it's almost similar. So I would suggest, if possible, go back to the video and watch this one. Else I'll give you a quick summary over here as well. So the approach that first of all, let's discuss how do we calculate a palindrome in the most efficient way. So let's suppose there is a string something like this, and how do we know whether this string is a palindrome or not? We know that once we reverse a string, and if it is same as the original one, it's a palindrome. And the most efficient way is using two pointers. We put one pointer over here and another pointer over here, and then we check whether these two values are equal or not, and then we keep on increasing our start and we keep on decreasing our end until unless our start exceeds end. So this is the approach we use for calculating palindrome. So how can we use something similar approach to calculate how many total palindromic substrings are possible, right? So how about I tell you that take one string and take two variable for this string, consider two values left and right. Each time the left will exceed to the left hand side and the right will exceed to the right hand side. And every time you just have to check whether the value at the left hand side and right hand side are equal or not. If they are equal, keep on expanding your left and right until unless it goes out of bound. Okay, so just to clarify this, let's suppose you are at index 2 right now. Your I is 2. You are on this index, right? So what you're going to do, you are going to increase your you have two variables left and right. Okay, currently both of the values are at the same point, that is C. Now we are saying that is that L and R, that is 2 right now, are they in bound? Yes. Are these both values equal? Yes. Then in that case we will expand our left and right. We will decrease our left so that it goes to this, and we will increase our R so that it goes to here. And then this from this while loop we will again check whether these two values are in bound. Yes. And are these values equal or not? If they say yes, they are equal, then again we have encountered one more palindrome, and we will do count plus plus, and again we will do the same thing. We will decrease our left pointer and increase our right pointer, and then we will check whether both the left pointer and right pointer are in bound and are equal. If they are, that means we have encountered one more palindrome, and we will do count plus plus, and so on. So that's the approach we will be going with. That's where we will be using a recursive call, and that's why we say that it's a dynamic programming solution, because we are using our old solution to find the newer ones. We are calculating the middle part one, and then we are expanding. So we are kind of using the old values or the overlapping values to find out the current count. So that's where the helper function helps us. The last point that I want to mention is that you can see that we have used two helper function. One is pointing to the exact index. Let me quickly show you. I was showing you this example, right? In here we can, let's suppose we are starting from this index, right? Let's suppose the string was something like this, and at the end of the day we are at this index, and through this index we got to know that okay, this is a palindromic substring, right? So we can see that this was a odd odd length number, right? So through this we were able to expand each value one at a time, and we were able to figure out that yes, this is one of the palindromes, right? But what if there is a value something like this? Here, even though I start with C, I can see that even though I expand my left and right in such a way, I'll still not be able to figure out any palindromes, right? Although single values are palindrome, I'm talking about in general, we will be able to find out okay, these okay, these single values are palindrome or not, but we will not be able to figure out that yes, this is actually a palindrome, but due to our approach we will not be able to figure it out, right? So you know what's the best way? The best way is to consider your starting and ending position in such a way that it catches two values at a time, that is I and I plus plus. So it will catch two values, it will check whether this ith or the left and the right is equal or not. If they are equal, go ahead and decrease your length, decrease your um, left and right, and then check whether they both are equal or not. If they are equal, decrease your length L and increase your R, that is right, and then check whether they are equal or not. And at the end of the day, you can continuously increase your count, and at the end of the day you can just return. So this was a small approach. I hope this helped. uh, I'll also provide the solution in the comment section, but that's all from my end. Thank you.